Gemini 3.6, GPT 5.6, Sol, and Grok 4.5 all want the same job, your daily coding agent. I ran the same 5 tests on all 3: cost, coding benchmarks, speed, context limits, and deployment. And the biggest surprise is that the cheapest model on the spec sheet isn't actually the cheapest model once you turn on the settings most people actually use. By the end of this video, you'll know exactly which one deserves your API key and which one is quietly padding its bill. Here's the number everyone leads with. Grok 4.5 charges $6 per million output tokens, the lowest sticker price of the 3. Gemini 3.6 sits close behind at $7.50 per million output, with input priced at $1.50. GPT 5.6 Sol charges $30 per million output tokens and $5 per million input, 5 times Grok's rate and 4 times Gemini's. On blended price, a community-reported estimate from BenchLM puts Gemini 3.6 around $4.50 per million tokens and Grok 4.5 around $4, both in the same neighborhood. GPT 5.6 Sol lands at $17.50 blended, more than 4 times either rival. Cached input tells a similar story. Gemini charges 15 cents per million cached tokens, Grok charges 30 cents, and Sol charges 50 cents. If your workflow reuses the same system prompt across thousands of calls, that cache rate compounds fast. There's a directional finding worth flagging here too. Gemini 3.6 Flash reportedly uses about 17% fewer output tokens than its predecessor, according to community consensus tracked by Apodog, which means its effective cost per task is even lower than the sticker price suggests. Sol, by contrast, burns more tokens because it's doing deep reasoning before it answers, so you're not just paying a higher rate, you're paying that higher rate on more tokens. Grok 4.5 wins this test on the headline number. But that headline number comes with an asterisk I'm saving for later in this video, because the $6 price tag isn't the price most serious users actually pay. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. That gap isn't rounding error. That's the difference between running an agent all day and rationing your calls. My name is Brian, and I spend most of my week digging through AI products, benchmarks, APIs, and pricing pages to figure out where these tools actually differ. This is the test that decides whether an agent finishes the job or breaks something in a real codebase. GPT 5.6 Sol leads every measure I could find. On the Artificial Analysis Intelligence Index, Sol scores 58.9 against Gemini's 50, a clear and independently tracked gap. On Deep SWE, which measures long-horizon software engineering work, Sol hits 73% while Gemini trails at 49%. Grok 4.5 has no published Deep SWE score at all. On SWE Bench Verified, which grades models against real GitHub issues instead of toy problems, Sol scores 96.2% according to Vellum's leaderboard. Grok 4.5 scores 86.6% according to swebench.com. Those numbers come from 2 different sources, so treat the exact gap as directional. But a 10-point spread on the same style of benchmark is not something you can wave away. Gemini 3.6 has no published SWE Bench verified figure I could find, an honest gap rather than a bad score. Sol's Goldie Bench head-to-head record adds another data point. It beats Claude Opus 40 wins to 7, beats a mixture of agents setup 31 to 10, and beats GLM 38 to 9. GPT 5.6 Sol wins this test clearly, and it's not close. If your coding agent needs to handle a genuinely hard, multi-step refactor without supervision, this is the one number in this whole video that should carry the most weight. That's not one benchmark, that's a pattern across matchups. Here's where the scoreboard flips hard. Gemini 3.6 runs at roughly 304 tokens per second, independently measured by artificial analysis. Grok 4.5 runs somewhere between 91 and 119 tokens per second. GPT 5.6 Sol runs at just 61.7 tokens per second, less than a fifth of Gemini's throughput. Time to first token matters just as much as raw speed, especially for interactive work. Gemini answers in roughly 12 to 15 seconds. Grok answers in a similar window, 13 to 17 seconds. Sol, at max reasoning effort, can take up to 154 seconds of hidden thinking before it produces a single visible token. So, the model that just won the coding benchmark test is also, by a wide margin, the slowest model in this comparison. Gemini 3.6 wins speed outright, and the gap over Sol is roughly 5 to 1 on throughput. If you're running an agent loop that fires dozens of calls a session, that gap turns into real wall clock time lost every single day. That's over 2.5 minutes of silence. Stick with me because the last 4 tests are where this decision actually flips. Now stick with me because this is where the practical differences start to matter more than they sound. Gemini 3.6 and GPT 5.6 Sol both handle roughly 1 million tokens of context, a genuine tie on input capacity. Grok 4.5 caps out at around 500,000 tokens, half of the other two. The bigger gap shows up on output. GPT 5.6 Sol can generate up to 128,000 tokens in a single response. Gemini 3.6 caps out at around 65,000 tokens, roughly half of Sol's ceiling. Grok 4.5 has a practical output limit of somewhere between 32 and 64,000 tokens, the smallest of the three. For most day-to-day coding tasks, none of these ceilings matter. You'll never generate that much text in one call. But for a full codebase refactor or a long-form document generation task, Sol's output ceiling is a genuine structural advantage. GPT 5.6 Sol takes this test on output capacity, with Gemini and Sol tied on raw context size. All three models advertise large context windows, but they're not all the same size, and the output ceiling matters just as much as the input ceiling. If you're feeding an agent a full repository, that's a real constraint. The last test is about whether you can actually use the model the way your workflow needs. Gemini 3.6 accepts text, image, video, audio, and PDF input, the widest range of the three by a clear margin. GPT 5.6 Sol handles text and image only. Grok 4.5's modality support isn't independently confirmed in the sources I checked, which is itself worth noting since that's a gap in the documentation, not a confirmed weakness. On deployment reach, Gemini 3.6 and GPT 5.6 Sol are both available globally through their respective APIs. Grok 4.5's EU availability is still pending, according to the sources I reviewed, which is a real limitation if your team or your users are based in Europe. But on the combination of modality breadth and global reach, Gemini 3.6 wins this test clearly. If your agent needs to process a screen recording, an audio note, or a PDF spec sheet alongside code, Gemini is the only one of the three that handles all of that natively right now. All three are API only. There's no local or on-prem option for any of them, so that part's a wash. Gemini 3.6 wins on speed, running at roughly 304 tokens per second, nearly 5 times Sol's throughput, and it wins on deployment with the widest modality support of the three. It's also priced close to Grok on cost, at $750 per million output tokens, with a token efficiency edge that makes its effective cost even lower. GPT 5.6 Sol wins the test that decides raw capability, 96.2% on SWE bench verified, 73% on deep SWE, 58.9% on the artificial analysis index, and a Goldie bench record that beats every rival it's been tested against. The cost is real too, $30 per million output tokens and up to 154 seconds of hidden thinking before it answers. Grok 4.5 wins on the sticker price, $6 per million output tokens, and it holds a respectable 86.6% on SWE bench verified for a fraction of Sol's cost. Its ceiling is context size, at half of what the other two offer, and its EU availability still isn't confirmed. For most people running high-volume agentic work, Gemini 3.6 is the default. It's roughly 5 times faster than Sol, priced close to Grok, and its multimodal input makes it the most versatile agent of the three. If you need the absolute best coding and reasoning quality and budget genuinely isn't a constraint, GPT 5.6 Sol is the clear champion. Its benchmark lead isn't marginal, it's a real gap across every measure that exists. If you're cost-sensitive and want a solid all-rounder with the cheapest tokens, Grok 4.5 is worth choosing. If someone handed me zero context and asked which to start with, I'd pick Gemini 3.6. The decisive reason: it delivers the best speed-to-price ratio of the three, and for the vast majority of coding workflows, that ratio matters more than squeezing out the last few benchmark points. Here's the thing marketing never puts on the pricing page. Grok 4.5's $6 per million output rate is the number everyone quotes, but turn on priority processing and that rate roughly doubles to around $12 per million. Add web search to your agent's toolchain and you're paying roughly $5 per 1,000 calls on top of that. The model that won Test 1 on price can end up costing more than the one it undercut, once you turn on the features a real production agent actually needs. If you want to see how these three handle a real multi-file coding task, instead of just benchmark numbers, that's the comparison to watch next, and it's where this ranking might actually flip.